Hey everyone, hope you guys are doing well. So in this video we're going to be discussing another important concept, and that is writing the CI pipeline for a microservices based application. And there are a lot of tutorials on YouTube implementing a CI pipeline, but none seems to discuss the actual process of writing the CI pipeline, right? Because let's suppose you've joined a company, a new company, and you have no idea about the product they are building, and you have been told to write the CI pipeline of one of the microservices based application which they are building. So they have provided you the GitHub source code, and now they want you to write the CI pipeline, right? So before writing the CI pipeline, there are a few things which you need to know. So first thing is you have to run the application locally, right? And not only you have to run the application locally, but you have to understand the working of the application. Only then you will be able to deploy it on cloud or any Kubernetes cluster, right? So to run the application, you need few things. So the first thing is you'll go to the developers who has built this microservices based application, and you'll ask them uh, to provide the environment variables which is required to run these applications or these microservices based services. And you will also ask if there is any dependencies or any like let's suppose you have a Node.js microservices, right? And that microservices talks to a database. So for that microservices to work, you need to have a database as well, right? So you will ask your developer, like, please give me the list of environment variables needed to run these service or these services, and also provide the dependencies, or also if there is any architecture diagram, also share that as well, because that is going to help me or you understand the whole architecture and the system and the working of the whole microservices based application. So here, to explain the whole process, I've got a microservices based application, and in this microservices based application we have got 1 2 3 4 5 6 7. We've got 7 microservices, and to run this whole system or these microservice based application, we need to have few databases as well. So these microservices depend on 3 databases, and each of them has some environment variables as well. So before going into the database side of things and showing you the environment variables, I'll discuss these microservices, and then we will discuss the first step, that is writing the Docker file, because you have to write the Docker file. That is the first step, and then after writing the Docker file, you build those microservices, and then after building that, you have to run that locally. So let me show you the application, and then we will move on to the writing of Docker file, and then we'll continue with the rest of the process. So I have this application up and running in my browser. Let's open this, and first thing first, it has an authentication microservice. Let's create an account first. Actually, I need to create an account. Okay, let me refresh to. Okay, it's still not working. Let me check. I think this is working. Let's pull this down. Let's start this again. So it it will take some time because it has to talk to the databases, and databases usually take some time to come up, and once they are up, then our application will come up, and then it will establish the connection, and then we will be able to access it from the UI. So let's try. Hopefully this time we will be able to access. So I'm going to create an account. So this is basically the first microservice that we have, which is the authentication microservice. As you can see, we have successfully created the account, and let's log into the account. And so we have 1, 2, 3, 4, 5, 6, and then another one. In total we have 7 microservices. So this is the product microservice, where we get the list of all the products, product catalog. This one is the order management microservice. This one is the inventory management microservice, and then we have a microservice related to the shipping, and then we have a profile management one, which is the actually the authentication one, and then we have a contact us microservice. So let's try to add some. Okay, it's for some reason it's throwing this error. I believe it's still taking some time to establish the connection. For that reason it is giving us this error, if I'm not mistaken. So in the meanwhile, we will browse with the rest of the application. We can log out. That's another feature. Let's refresh this once again. This time we should be able to add this to. Okay, it's still throwing the same error. Let's log out and log in again. Hopefully we should be able to perform. Okay, still not working. That is not good. I don't know what is going wrong here. All the microservices are up and running, so we should be able to perform these actions. Okay, so now we were able to add this to the cart, and let's add a few more. So the reason it failed initially was, like I mentioned before, these databases usually take some time. We have a MySQL database, we have a MongoDB database, we have a Postgres database, and rest of these applications depend on these databases, right? For them to be able to function properly, first the databases should be up and running, and once they are up and running, then the microservices establish connection to those databases. And the reason why we were getting those errors was our databases were not ready, and for that reason our microservices were also down, and for that reason we were getting that error. Okay, so the beauty about this microservice based architecture is that when we tried to add this product to cart, this functionality was not working, right? But rest of the application was working fine. We were able to log in, we were able to access the rest of the features, but only the add to cart feature was down, right? So that is the beauty of writing microservice based application. So let's add a few more, and let's now go to order management. As you can see, we have these two, so we can place the order, and here we can extend this to like actually implement a payment processing system, maybe Stripe or something of that. But right now, since I have to discuss a lot of things, so I have to keep things simple, because this is going to be something which will not only we're going to implement the microservices, but not only we're going to write those Docker files and CI pipeline, but also we're going to implement the CD and implement a Kubernetes cluster and all of that. So this is going to be quite a lengthy video, so for that reason I have tried to keep things as simple as possible. So this is the application. Let's log out and let's bring this down. We don't need this anymore. So first thing first, we have to write the Docker file for each of these applications, right? So the first one is contact and support team. that is the first microservice, the contact us microservice. It's Python application, and to write the Docker file, the base image that we have used Python 3.9, and then the working directory is /app, and then we copy the requirement.txt, then we install the dependencies, then we copy the rest of the file, which was this one, the server.py, and then we expose the application on port 8000, and then this is the command to run this microservice, right? This is Python based application, the contact and support microservice. Then we have, I'll leave this one, I'm going to discuss the order management one. So this is a Spring Boot application, and to write this the Docker file for this, we made use of Maven and JDK 17. Maven, JDK 17, Slim. We use the Slim image. Why? Because we don't need all those packages and all those libraries which comes with JDK 17. We only need the bare minimum, and that is what we get in this Slim version. And then this basically allows us to reduce the size of the image. Then the similar to other one, we specify the working directory, then copy the files, expose the application on port 9090, and then this command to run the Spring Boot application. Then comes the product catalog microservice. This is a Node.js based application, and the base image that we have used is Node 17. Then we specify the working directory, then we copy the package to JSON, then we install the packages, then we copy rest of the files, and then we expose the application on port 3001, and then the command to run this application, right? Then comes the product inventory microservice. This is again a Node.js Python based application. So the base image that we have used is Python 3.9. Then we specified the working directory, then we copied the requirement.txt file, then we install the packages, and then we copied the rest of the application source code, and then expose the application on port 302 actually, and then we write the command to start this application. Then comes the profile management or the auth microservice. This is again a Node.js based application. So we use the Node 14 as a base image, specified the working directory, then we copy the package.json, install the packages, copy the rest of the application code, and then expose it on port 3003, and then run the application using this command. Then we have the shipping microservice. This is actually a Go based microservice, and to run this or to dockerize this, the base image that we have used is Golang 1.20, and then we specify the working directory, copy the go moth and go sum to the working directory, and then we install the dependencies, copy rest of the source code, expose it on port 8080, and then specify the command to run this go microservice. Then comes this one, the e-commerce UI. We have used a React application, which is this one, and then what we have done is we have created a Node.js application which will act as an entry point to our application. And what we're doing is, if I show you, we have this docker file here. We use the Node 14 as the base image. We specify the working directory. We copy the server folder to this, and then we specify the working directory and install the packages in this server folder, and then we move back to the working directory and we copy the client folder to this client inside the container, and we specify the working directory. We have to move, this is basically means changing the directory, like similar to CD. We are doing CD to this location, and then we are installing these dependencies, and then we are building the React application, and then specifying the working directory, again changing the directory here, exposing the application on port 4000, and then starting this application. So this is what we have in terms of the microservices that we have. So if I show you actually this one, the e-commerce UI, it has this Node.js application. In the Node.js application, what it does is it builds the React application, and then it exposes the React application on the root URL, right? And then any request or any API request is then forwarded to the respective microservices, right? So this is what it is doing. With this, we are done with the first step in writing the CI pipeline. That was writing the Docker file for each of the microservices. So we have the Docker file for each of the microservices. Now we can build those microservices. So to build the microservice, you need to have Docker install. If not, you can install it using snap or apt-get install command. So after that, you have to build the microservices, and the command to build the microservices is docker build. This is the command. So docker build, and then you have to give the tag, and the tag would be, first you have to specify the name of the repository where you are going to push this image, and then the name of the image, and then the tag that you want to give, and then you specify then the location where this particular where the code actually is. So with reference to this folder, the code is here in my current folder structure. Currently I'm at the root, and which was microservices masterclass, and then the path to this particular microservice is /e-commerce UI. So that is the path. So if I do this, it will build this image and it will tag it with the latest tag. And now after building this image, I can run this microservice locally, and we have to repeat this process for all the other microservices. Say we have 7 microservices, we have to do the same for all the other microservices. Same for the product one. I'm gonna copy this from the readme. You guys, I'll provide the readme, don't worry, okay? You guys can do all of these on your side as well, and then paste it. So you have to build all these images using these commands provided here, and once you are done with that, then comes to the next step. So the reason why I'm not building it right now is because if I start the build process, it will take some time, and my internet is a little bit slow. It will take time downloading those packages. Those base images are generally quite huge. Some of them are in GBs. So if I do the build here, it will take time. So for that reason, I'm skipping this, but you guys can do this. I'll show you actually an easy way of building these images, especially if you have slow internet. That will save some time for you guys. So with this, we are done with building all the images, and the next step is, okay, we write the Docker file, we build the images, but still we have to run these images, right, with these Dockerized applications. So to run this application, we need to again go back to our developers and ask them, like, what are the environment variables needed to run each of these applications, and is there any dependency, like if any of these applications talks to any database, then that means this application, before running this particular microservice or application, we have to first run the database and make sure the database is up and running. So what you do is you write the Docker compose file and specify all the environment variables and all the images that you want to that are part of this application. So I've written the Docker compose file already, and I'm going to show you. So first thing first, as you can see, we have three databases. We're using MongoDB, we're using Postgres, and we're using MySQL. Okay, because our rest of our microservice, some microservices talks to MongoDB, some microservice talks to Postgres, and some talk to MySQL. For that reason, we have different or multiple databases. So let's start with the product catalog microservice. So the image that we are using is this one. If I show you the README just once again, what you do is, where is it? Okay, this was the command, right? So this was the command. Let me show it this way. So docker build, and then you give the tag, and then the path of the folder. That is what you do, right? So that is what I have done here. So for product service, this is the tag that I have given, and that is why I've specified the image as this. And here comes the important thing, the environment variables, which we were discussing since the beginning. We talked to our developer, and he said, okay, this particular microservice needs three environment variables. First is MongoDB host, second one is MongoDB port, and third one is a MongoDB database name. So it needs three environment variables. So he gave us the list, we specified them here, and he told us that the microservice or the MongoDB database name should be this. Okay, so based on that, we write this Docker Compose, and same goes with the rest of the application as well. We specify the image, we specify the environment variables, and then we specify the port, right? And if you notice here, we have a depends on for both of them, and both of them talks to MongoDB. That means these two have a dependency on MongoDB, which we have here, MongoDB database. So before, where is it? Before running these two microservices, we have to make sure that our MongoDB is up and running, right? So that is what this depends thing does. It will wait for the MongoDB to come up, and once the MongoDB is up and running, then it will run these microservices. Then we have the contact and support team microservice, which uses this image, then the environment variables, and then it also depends on the MongoDB, and then the port which on which it runs. Then the product inventory, then we have the profile one, and then we have the order management. So the product inventory microservice, it has these environment variables, and it actually talks to a Postgres database. So that is why we have a Postgres database running here. And also we have mentioned that it depends on the Postgres database, right? Then the profile management or authentication microservice, it has these environment variables, and it actually talks to the MySQL database, and that is why we have specified that it depends on MySQL database. And we have provision, or we have created the MySQL container here as well. Then we have the order management microservice, which has these environment variables, and it depends on all these other images or other containers. So it talks to MongoDB. So first, before running this microservice, MongoDB should be up and running. It also talks to product catalog, so product catalog should also be up and running. It also talks to product inventory, so product inventory should also be up and running. And it also talks to shipping and handling microservice, so that should also be up and running. So it has a lot of dependencies, so this will take some time to come up. And when I showed you that demo, so this one was the one which was giving us the error, and it was taking time to come up because it has all these these dependencies. Then finally we have the e-commerce UI, which is these environment variables, and it is also it also talks to these all these services, and it depends on all these services. So this is how we write the Docker Compose file. And once you are done with writing the Docker Compose file, and once you correctly specify all these environment variables, now what you can do is you can run this Docker Compose up command, and then we specify the -d command. When we specify the -d command, it will detach the terminal, and we will be able to use the terminal. Otherwise, if we don't specify this d, we won't be able to use the terminal. So for that reason we use -d, so it runs in a detached mode. So as you can see, all the containers has been started, and all of them are in running state, I believe, and we can access the application from here. So we have already showed you the demo. I'm not going to show you the demo again. So this is how we run the application, and we test the application, understand the functionality. So I'm going to bring this down. I don't need this, so I'll bring this down. So now that we understood the application thoroughly, we ran it locally, and now we are aware of the functionalities it has and how it works and how it talks to different services. The next step is actually is to write the CI pipeline. So whatever we have done so far locally, we have to do it in the CI pipeline, like building the image, pushing the image to Docker Hub, or whatever repository you may have. That is what we are going to be doing, right? So for this particular project, the implementation that I have decided is to use GitHub Actions. And to implement GitHub Actions, what you have to do is you have to create a folder with .github, and then inside that .github folder you create the pipeline, and the file for the pipeline must be a YAML file with a YAML or YML extension. So this is the CI pipeline that we have written in this file, and this particular pipeline will trigger whenever we push the code to the main branch or the master branch, or whenever we have a pull request or on the master or the main branch. So whenever we have these two scenarios, this particular pipeline will trigger. So what will this pipeline do? It will build the image and push the image to Docker Hub. That is what it is going to do. So first thing first, to push the image to Docker Hub, it needs to have the credentials of the Docker Hub account, right? So in my case, my Docker Hub username is this, so that is what I have specified here. But this just the name is not enough. You need to have the token, and that is what you're gonna need. So I'll show you how to get that. Let's continue with the rest of the pipeline. So in the job section, we have created a job that is build and push. So that is what this job does. So first thing first, it runs on Ubuntu Linux. That is the instance on which this pipeline will run, and then it checks out to the repository. Then using this action, it build the Docker images. So this one we have specified here right below, so I'm gonna show you. So first thing first, it logs into the Docker Hub account using the Docker Hub username and then the Docker Hub token. So once it is done with the login, it will build all these images. First time it will build all the images, right? Because when we push this for the first time, it will push build all the images and push all of them to Docker Hub. But what if What if, let's suppose, in the subsequent pushes, what if I only made some changes to this e-commerce UI microservice only? In that case, we don't want to build all these images again, right? We only want to build the one which has changed. So that is what this particular action does. So it will filter, it will check like which of these folder has changed, and whichever has changed, it will only build that folder and push that to Docker Hub. So this particular job filters the folder that has changed, and in this tab we will check, like here in the filters tab, if this e-commerce UI has changed, then we need to build it again and push it again to Docker. So this step is build, okay, build and push. It has both build and push at the same time. So I was thinking like it has two separate steps, one for build, one for push, but it takes care of the both build and push in just one step. And then same goes for these ones. It builds the product catalog. Now it checks for the product catalog in the filter step, and if this is true, that means it has also changed, so it has to push this, build and push these particular services. So same goes for all the other services. So this is what we are doing. We are checking if this particular folder has changed. If it has changed, then we're going to build it and we're going to push it. So this is how we write the CI pipeline. The last thing which I need to show you is, I'm going to take you to Docker Hub. Docker Hub, this one, this is my Docker Hub account, and so what you do is, I believe in the settings section, no, I think it is in the profile section. This is not, where is it? Account setting, I believe. Access token. So you can see personal access token. You have to click here. So generate a new token, and you can like do this, and then read and write, and then generate. So you have this token, right? You just copy it, and then go to your GitHub repository, go to this settings tab, and then click on this secrets and variable, click on action, and then you have to just add new repository secret, and then just paste it here, give the name which we have given here. The name was this one, right? You have to do this, and then click the add secret button. I already have the secret, so I'm not going to add that here. Similarly, you have to add the Docker Hub username as well, right? So with this, our pipeline is ready. So what I'm gonna do is, I'll make some changes to the e-commerce UI microservice, and I'm gonna make some change to the home, and then I'll do app. So let's remove this one, right? Or what I will do is, welcome to, say, instead of the e-commerce app, I'll say my e-commerce app. Okay, that is the change which we have made. And what I'm gonna do is, I'm gonna push this whole code to GitHub -m, add it my to the UI app di title. So that is what we have done, and then git push. So when we do the push, it should trigger the pipeline, and I'll show you, it will actually trigger the pipeline. So as you can see, we have pushed this code, and then now if I go to this actions tab, As you can see, it is actually running this pipeline. This was the one which we have just committed, and in this particular commit, I've only changed the e-commerce UI microservice, so it will only build that one. The rest will not be built in this particular action. Why? Because I've already tested this whole flow, and while I was testing this whole flow, I have pushed rest of the microservices, and so this is the one which has changed, so it will only push this one, so which is what it is doing. So it will take some time, and then it will push, and we can actually confirm it from here. So if we go back to home, and repositories, I want to get my repositories. Repositories, let it finish. The pipeline is still in process. It will take some time. So okay, you can see that the job has been completed. It has been, we have got the green tick here, and also at the bottom, if you scroll down, it has said complete job. So now if I go to my Docker Hub, and if I do refresh of this page, I should see that latest image there. This is the image which was last updated just 1 minute ago. So this was the latest image of the e-commerce UI, right? So this is how we do the CIE of any project. And in the next step, what we're going to be doing is we're going to implement the CD, and we're going to provision this whole we're going to implement this whole or deploy this whole microservice application in a Kubernetes cluster using ArgoCD.